So the second part of our 4.4 notes is working backwards to find theta. So if we're given a trig value of theta, we can figure out what theta is, either in radians or in degrees. But most of our work here in AP Pre-Calc is in radians. And so if you're trying to do this, say, without a calculator, then the first thing you need to do is determine the reference angle. And what is a reference angle? So a reference angle is a quadrant 1 angle. And it's in a quadrant 1 angle. It represents the angle between the x-axis and the terminal side of the angle you're looking at. So what that means, it's often denoted by alpha. What that means is in quadrant 1, we don't really need a reference angle because the angle we're talking about is between the x-axis and the terminal side. So theta is the same as the reference angle. In quadrant 2, say we had this obtuse angle here, then the reference angle we're using is from the x-axis up to the terminal side. So we do this for speed quizzes a lot. I did this with speed quizzes without really getting into the details of it. But like, remember, if you needed to find the sine of 3 pi over 4, I said, well, just figure out the sine of pi over 4 and then apply that to this quadrant. So pi over 4 is the reference angle there. If you have a quadrant 3 angle, so going from 0 down to quadrant 3, this whole thing, then your theta is this reference angle. This little reference angle here. And if it's in quadrant 4 from the x-axis here, that's your reference angle. So how do we find those values? Well, in quadrant 2, it's always going to be pi minus theta, right? 180 minus 120 would give me a 60-degree reference angle, but we'll do this in radians. To find theta, or to find alpha, in quadrant 3, theta is some big angle, like 210 degrees, or 7 pi over 6 radians. And we would need to subtract pi radians, to figure out what the leftover piece is there. And then in quadrant 4, you've got this full circle minus your theta, which lands you here, and the leftover piece would be alpha. So full circle is 2 pi minus theta, that's equal to alpha. If we're trying to solve between 0 and 2 pi, then we determine which two quadrants theta must lie. So this is based off of all students take calculus. And then finally we find theta. So theta, if this is a non-calculator problem, theta will be a pair of our common angles. All right, so let's figure this out. So number 6, the reference angle, which is alpha. Think about when is cosine theta, when is radical 2 over 2 involved when we're talking about cosine. That's at the pi over 4 angle. It's just that we're in some other quadrant because cosine is negative. So where is cosine theta less than 0, or where is it negative? That happens in quadrants 2 and 3. So when we're doing common angles, we don't have to think too hard about this, but basically give me the pi over 4 angle that's in quadrant 2, 3 pi over 4, and give me the pi over 4 angle that's in quadrant 3. The pi over 4 angle, 5 pi over 4. Sorry. The math on that works out if you wanted to do, if we're trying to do like, what is the pi over 4? We've got 3 pi over 4, and then we're subtracting pi, and that comes back to our reference angle. So you don't really have to check your work, but you're just giving me that version of that angle in whatever two quadrants you should be in. Solve the equation between 0 and 2 pi means within one full circle. We're not going beyond one full circle. Otherwise, there'd be infinitely many answers, which we'll get to. Just one full circle. All right, so when is tangent equal to radical 3? For tangent, I like to do this. Radical 3 over 1, y over x. Figure out the reference angle first. So which one of our three quadrant 1 angles has a y value of radical 3 and an x value of 1? If it helps you, write out like a speed quiz, write out these two, at least these two angles, pi over 3 and pi over 6. All right, so which one of those two is y over x? So here the y numerator is radical 3. Here the x is 1. So we must be at pi over 3 for our reference angle. And then when is tangent theta positive radical 3? When is it greater than 0? That happens in quadrants 1 and 3. So one of our answers is the reference angle. Pi over 3 in quadrant 1 is pi over 3. What's the pi over 3 angle in quadrant 3? 4 pi over 3. Okay. Secant theta is 2 radical 3 over 3. Remember, that means that cosine theta, you can flip this around if you want, this has been rationalized. That's the rationalized version of radical 3 over 2 before it got flipped. So really I'm saying secant theta equals 2 radical 3 over 3. I like to just think of this. So what is my reference angle? Well, if we have an x value, it just crashed on me. If we have an x value, oh, sorry, I thought I had to rewrite that. If we had an x value of radical 3 over 2, we must be at the pi over 6 angle. So our reference angle is pi over 6. And which two quadrants are we in? Cosine is positive in quadrants 1 and 4. So give the theta in quadrant 1, pi over 6. What is the pi over 6 angle in quadrant 4? 11 pi over 6. All right, for our next one, cotangent theta is undefined. Remember, undefined means that we were dividing by 0. Now, it could be 1 over 0, or it could be negative 1 over 0. So remember, cotangent's undefined at one of our non-quadrant angles, where the x is 1 or negative 1, and the y is 0. So that's y is 0 on the x-axis here. So that's either 1, 0 or negative 1, 0. So I don't need quadrants for this one. I can just say, oh, it's one of these two angles. So theta is either 0 or pi. Those are the two places where cotangent would be undefined. When is sine theta equal to 1? So if it's not a radical 3 over 2, radical 2 over 2, or 1/2, if it's just 1 or 0, again, you must be on a non-quadrant angle, which means 0, pi over 2, pi, or 3 pi over 2. So when is the y coordinate equal to 1? That only happens at the top, which is at pi over 2. Because the opposite of that down here, sine theta is equal to negative 1, so that's not the same. And in the other two places, sine theta is equal to 0. So it's possible to only get one answer for the ones that are equal to 1 or 0 or negative 1. When is cosine, this should say theta, when is cosine of theta equal to 0? So this is when the x coordinate is equal to 0. At the top of the circle, the x coordinate is 0, and at the bottom of the circle, the x coordinate is 0. So there are two places where cosine is 0. So theta is pi over 2 and 3 pi over 2. All right, now what if we need to use a calculator? So there are two ways to do this. You're allowed to use a calculator. So you can go through all of the same steps that we're doing here. Or remember, anytime we're given a calculator, we're allowed to solve graphically. So I want to know, when is tangent theta equal to 3/7? So algebraically, I have to figure out, well, first, what's the reference angle? So the first thing I have to do is figure out alpha. And if I want to figure out alpha, that would be, what's the inverse tangent of 3/7? So make sure your calculator is in radian mode. If it's not, press mode, change it down to radians down there. And then inverse tangent of 3/7. So I'm going to leave this on my screen, but I get about 0.40. I'm going to just say this. Alpha is equal to 0.404 dot, dot, dot. I don't want to round that. You don't want to round until your final answer. Okay? Which two quadrants is tangent theta greater than 0, since this is positive 3/7? That's quadrants 1 and 3. Okay, how do we find theta? So in quadrant 1, theta equals alpha, which is 0.405. So I'll round it now. And then in quadrant 3, remember back here, in quadrant 3, to get theta, you can say, well, alpha is 0.40 whatever. So to figure out theta all the way around, that's pi plus that little alpha. So pi plus alpha is about equal to, oops, I didn't mean to do it twice. This first one, 3.546. Both of those answers are in radians. You don't have to label, like, you don't have to write the word radians, but it might be nice to have for your notes so you remember that you're finding angles. Okay, now that is kind of a long way to do things. We can always solve an equation graphically, right? So here's the key. This is the domain. So what if you want to solve this graphically? First of all, type this in. The left side of the equation equals the right side. So I can't get to y1 for some reason. So tangent of x, we just have to put. And then remember, the right side of the equation is the number 3/7. Your window should be your domain. So we're going from 0 to 2 pi. Now, it doesn't really matter what you count by. So you can just leave that as 1 if you want right now. And then you can zoom fit. And what's happening? Tangent x equals 3/7. Okay, sorry. Zoom fit was a poor choice. We don't need to zoom fit. Look at these crazy values here. Instead of zoom fits, we only need to know when tangent theta hits 3/7. So how about we just go from 0 to 1? It's probably better than zoom fit. So the tangent graph is in red. The line 3/7 is right here. I can find the points of intersection. So let's see, where was my cursor? Okay, my cursor is on the right side. Enter, enter, enter. Great, so there's the one answer, which we got. And then if I want to find the other one, it's better to be, instead of on the tangent curve, hop down to the black curve so that you can just, or the straight line, I should say, so that you can just get yourself closer by arrowing left. You need to be closer to the other point of intersection. That's good enough. And then enter, enter, enter. 0.405. So I would prefer to solve by graphing, but let's write those steps down. So y1 was tangent of x. y2 was 3/7. Might as well write down our x min, x max. So x min was 0. X max was 2 pi. Y min was 0. And y max was 1. And that was, I just did 0 to 1 because I just wanted to get to 3/7. I didn't care about the rest of the graph. And that's it. Okay, now there's this follow-up question at the bottom, hopefully, of your notes. It says, what if the answers for theta were not limited to one circle? So we want infinite answers. How do we make adjustments? So let's take a look at this answer. Theta equals 0.405. Now, this is just a coterminal angle question, right? How do we make a coterminal angle to 0.405? We could add a full circle to it. So we could add 2 pi. We could subtract 2 pi. We could add 4 pi, 6 pi, 8 pi, whatever. So the way to say that, to get an infinite number of answers, is to say we're going to add 2 pi times k. Our AP test likes to use k. And k is an integer. K can't be a fraction or anything because that messes things up. But if k is 1 or 2 or 3 or -1 or -2 or -3, that gives you an infinite number of circles you can add to this. Another way to say k is an integer is to say k is an element of the number set z. This capital Z with an extra line denotes integers. The other answer would have been 3.546. And again, add 2 pi k. You have to say k is an integer, either in words, which is what the AP test will do for multiple choice answers, or you can use this notation. That's okay too. But you have to say something. A lot of our AP questions will want infinite answers instead of just within one circle, but they will do both. All right. So what about this one? We can choose. Now, I want to show you algebraically just in case you choose to do it this way. For your calculator, anytime you get a reciprocal function, change it to sine, cosine, or tangent. So if cosecant is negative 5 halves, sine is negative 2 fifths. Now for your calculator, to find alpha, don't type in the negative. So alpha, we're going to do inverse sine of 2 fifths. We want it to find the quadrant 1 reference angle, and we can't have it finding quadrant 2 or quadrant 4 or something. Or I mean quadrant 3 or quadrant 4 or something like that. So if I do second sine of 2 fifths, I get that alpha is 0.411, etc. Which quadrants should I be in? Where is sine negative? Sine is negative in quadrants 3 and 4. So how do I find theta? Well, theta in quadrant 3 would be pi plus alpha, right? Because you're talking about 180 plus that extra bit. And then in quadrant 4, it would be 2 pi minus alpha to get your angle. Okay, so our angles are about, so here's So here's alpha. So plus pi. So 3.553. And then the other one is 2 pi minus. Go back and grab this alpha. If your calculator is older and doesn't let you do that, just type this into maybe more than 3 places, just for accuracy's sake. And then we get 5.872. What about graphically? What if I want to do this graphically? You can't type in cosecant. So again, do this. Y1 is sine theta, or x. Y2 is negative 2 fifths. The x window is going to go 0 to 2 pi. What about the y values? I only need to capture negative 2 fifths. So I'm going to go, the minimum would be negative 1 and the max would be 0. Or you could do negative 1 to 1 or whatever. So 0 to 2 pi is already in there. Change the minimum to negative 1, max to 0, and let's graph. Oops, how about I need to type this in first. Okay, so sine of x and negative 2 over 5. That's better. So I see 2 sections there. I can find the intersection. Enter, enter, enter. There's 1. And the other one, I like to be on the black line or the horizontal, whatever it is, so that I can get closer easily. Enter, enter, enter. There's the other one. All right, this one I'm just going to solve graphically. So I'm going to put in to y1. What's happening here? Going to put into y1 sine x, y2 negative 0.126, and I'm going to keep the same window I had before. So really all I have to change is that this is negative 0.126. Intersect, enter, enter, enter. So we get that theta is about equal to 3.268 radians, and I forgot to hop over to the other one. So here I know I'm closer to the right side, so enter, enter, enter. 6.157. Those would have labels of radians if you want to put labels on, but you don't have to. So the nice thing about graphically is that it follows what we've been doing. It's a good review of what we did for a lot of the first semester, especially first quarter. And there's no need for a reference angle there. Okay. What if we want to make these answers infinite? So for 13, you have to do it separately, but the infinite number of answers for theta would be 3.553 plus 2 pi k, where k is an integer. I like writing the shorthand. And that's theta equals, sorry. And the other one is same thing. You just add 2 pi k with the stipulation that k is an integer for every single problem if they're asking you that. And 14 is similar. All right, that's it for the notes today.